Hello and welcome to Linux Server Training 101. Today we're doing managing file and directory permissions. My name is Don Crawley from soundtraining.net. We're the Seattle, Washington-based IT training provider. We specialize in accelerated training for IT professionals. This video is based on Chapter 4 in my book, The Accidental Administrator, Linux Server Step-by-Step Configuration Guide. You don't have to have a copy to follow along, but if you'd like one, it's available on Amazon.com and through other resellers, or you can visit the soundtraining.net bookstore at soundtraining.net/bookstore. The video is based on CentOS version 5.8, although, frankly, with the commands that we're going to be using, it should work on pretty much any version of Linux, any distro, whether it's Debian, Ubuntu, Slackware, or whatever. Same thing for Unix systems as well. These are pretty common commands. So what are the types of file permissions available in Linux systems? There are three, and the first one is read permission. That's when you can view a file's contents. Next is write permission. That means that you can change or delete the file. And finally, there is execute, which means you can run the file as a program. Now, we have the exact same permissions for directories, but they mean different things when applied to a directory. So for the directories, read means you can list the contents of the directory. Write means you can add and remove files in the directory. And execute means you can list information about the files in the directory. Permissions are applied to one of three entities, or all three. First, the user, then the group, and finally, the world or other. The user represented by a small u, the group represented by a small g, and other represented by a small o. Understanding permissions is pretty straightforward, but let's go through it anyway. We'll start with the output of the ll command, which is an alias for ls-l. It's a long listing, so it gives you details about the contents of a directory. Immediately below the command is the total 20 statement, and that's simply the number of blocks in the directory. Then going from left to right, on the far left is what looks like one fairly wide column, but it's actually 10 single character columns, and the leftmost one specifies the type of file. A hyphen means a regular file, an L means a link, as we can see on the second one from the bottom. That's a symbolic link linking file 4 to a different location. And a D means a directory. Again, as you see at the very bottom of the output, that's a D indicating that files is a directory. Now continuing on, the next three columns are the permissions of the user. So the first three files for the user have read and write permission enabled, but not execute. The fact that the third column in the group is a hyphen means that the execute is not enabled. Now at the bottom, for the symbolic link for file 4, all three permissions are enabled. So the user has read, write, and execute, and same thing for the directory, read, write, and execute. Continuing on is the permissions of the group. Read and write for the group on file 1, file 2, and file 3, read, write, and execute on file 4 and the directory files. And then finally the permissions of the world or other. And as you can see, for file 1, 2, and 3, the world has only read permission. For file 4, the world has read, write, and execute, and for the directory files, the world has read and execute permission. Next column over is the number of links pointing to the file. That'll always be at least one for a regular file and two for a directory, and perhaps others as well. Next is the owner of the file. That's the user. Now the group owner. So for file 1, the owner is Don, or the user, and the group owner is engineers. Next is the file size. Now the file's last modification or creation, date and time. The file name itself. And then for links, the target of the link. That would only be for a symbolic link, which, if you're not familiar with that, it's basically like a shortcut in Windows. Now, the disclaimer before we do the demos: this video is provided solely as a courtesy to you, our viewer. No guarantees whatsoever. Please don't attempt these procedures on a production server without first testing them for security and suitability in a lab environment. Just don't be experimenting with production servers. That's why you have a sandbox set up. Performing these procedures may open up your server to possible attack, even if you do them correctly. So make sure you have current backups and take precautions, including data encryption and additional access controls to protect sensitive data. Prerequisites. In order to do this exercise, you should have the following: a willingness to work in the Linux command line environment. Some people just like to point and click with a mouse, and if that's you, this probably is not for you. And also unrestricted root access to a Linux server. You don't absolutely have to have that, but you really want to get familiar with Linux. Equipment software requirements, really any distro of Linux will work, or any version of Unix, but the one that I'm using is CentOS version 5.8 if you really want to do exactly what we're doing, but these commands are pretty universal, as I mentioned earlier. Also, I used a Linux server running as a virtual machine under VMware Workstation. You could certainly use VirtualBox or any other virtualization software that you want, or use a physical machine if you want. That's entirely up to you. So now let's do the demo, and we'll start by doing a directory listing. I'll do an ls-l command, and because I have an alias, I could also do ll command. That's exactly the same thing. And you'll see that the first three files are regular files. The fourth file is a symbolic link, and the last file is actually a directory called files. The command that we're going to use to modify the permissions is the chmod command, or change modify, chmod. So let's start with entering the command. And now let's add the execute permission for the user. So we're going to type user and add execute, and we'll do that on file 1. Now once again I'll do an ll command, and you can see that I've added execute for file 1 for the user. Now let's go in, and for the group and other we're going to add full permissions. So we're going to type chmod go group and other plus rwx file 1. Once again, we'll do an ll command, and there you can see now everybody has full permission. That's not normally what you would do. Maybe there's certain situations where you might, but normally we wouldn't give full permissions like that. So let's take some of those away. Let's go in and do a chmod, and for group and other, we're going to remove rwnx, all permissions. So file 1, and I'll do an ll command, and now you can see that only the user has access to the file. No one else can. Let's go ahead and remove the execute permission for the user as well. So let's do chmod and u-x file 1, and again a directory listing, and there you can see it's now back to read and write for the user. Let's go ahead and make the group equal to the user. So we'll type chmod and group equals user file 1, and now you can see that the permissions for the group are equal to that of the user. Let's go ahead and put in the read permission for the other, for the world. So we'll type in chmod and other add read file 1, and a directory listing, and there you can see it's back to the way it was. One more command I want to show you. Just for grins, let's add execute for everybody on this. So we'll use the a statement. So chmod, helps to type it correctly, a plus execute, and file 1. And now you can see that I just gave all, that's user, group, and other, execute permission for file 1. Let's take it away. We'll do it the same way. Chmod a -x file 1 and ll, and now you can see it's back to the way it was. So those are what are called alphabetic permissions. We also have octal or numeric permissions in Linux and Unix systems, and frankly when I'm managing a server, this is what I use. I almost never use the alphabetic permissions. So even though they're easier to understand, this is just a lot faster and frankly a lot more flexible. We still have the same permissions. We have read, write, and execute, but now read is represented by a number, and it's the number 4. Write is represented by the number 2, and execute represented by the number 1. No access is represented by the number 0. And we can use these in various combinations. So, for example, if I want to give read, write, and execute permission to someone, I would type in the number 7, because 4 plus 2 plus 1 equals 7. If I want to give read and execute, I would type in the number 5. 4 plus 1 equals 5. If I want to give read and write, I would type in the number 6, because 4 plus 2 equals 6. If I want to give read-only permission, I'd enter 4, or execute only. Not sure why I would do that, but maybe there's a situation where I would, and I would only type in the number 1. They're given in groups of 3 numbers, and it really makes sense when you think about it. 664 means the user and group have read and write permission. Those are the first two sixes for user and group. 4 plus 2 equals 6. And the world has read-only permission. That's the third number, the 4. Now, there are also what are called special permissions, and they give us a little more flexibility. The first of the special permissions is the sticky bit. And we can add the sticky bit on world writable directories to prevent users from deleting other users' files. We add the sticky bit to the front of the permissions. So if we want to set the sticky bit on a directory, we would set the permissions as 1777. The other two types of special permissions are set UID, which allows you to specify that a command always runs as its owner, and set GID, which allows you to specify that a command always runs as its group owner. These are kind of like the run as command in Windows. In order to set UID, we would use the number 4, and in order to set GID, we would use the number 2. Now let's just take a look at some examples of using octal or numeric permissions. Once again, we'll do a directory listing, and now we'll change the permissions to 777. So that's read, write, and execute for everybody on file 1. Chmod 777 file 1. The directory listing, and there you can see we gave full control to everybody, user, group, and world on file 1. Let's take it away, so we're going to set it back to what it was before. We'll do chmod 664 on file 1 and do a directory listing, and you can see it's back to where it was. 6 means read and write, that's 4 plus 2, and 4 means simply read. Let's take away permissions for the other, for the world, on file 1, 2, and 3. So we'll do chmod 660 file 1, file 2, file 3. And we'll do an LL command. And there you can see we took away all permissions for the world, for other, on files 1, 2, and 3. Now let's set permissions for all of the files in the directory. So we'll do chmod 664 file, and then I'm going to put in a star, and that is a placeholder. So it's a wildcard. Let's see what happened. We'll do an LL command, and notice that except for the symbolic link, which is kind of an entity unto itself, we now have changed the permissions for everybody. That's not really what we want to do, especially on the directory files, and so let's go set it correctly. So we'll do chmod 777 files. Once again, a directory listing, and you can see we're back to almost the way we were, but not quite, because it wasn't full permission. It was actually read, write, and execute for the user and the group, and read and execute for the world. So let's set that correctly. We'll do a chmod 775, for files. And now an LL, and now it's back to the way it was. Finally, let's go ahead and set the sticky bit on files. Simple to do, chmod 1777 files. And we'll do an LL command. And now notice that the last permission listed on files is a T, which simply means that the sticky bit has been set. And that means that even though it's world writable, no one other than the owner of a file can delete it. Just a way of providing some protection. So that's a look at file and directory permissions on systems running Linux or Unix. If you'd like more information, certainly visit our website at www.soundtraining.net. You can pick up a copy of the book or other books for IT professionals at our bookstore, soundtraining.net/bookstore. I blog at soundtraining.net/blog. Videos, more of them, are available at soundtraining.net/videos. And you'll also find us on Google+, Facebook, and Twitter. If you want more videos, you can use this button in the middle to go to our video channel. And if you'd like a companion book, The Accidental Administrator, Linux Server Step-by-Step Configuration Guide, visit our bookstore at www.soundtraining.net/bookstore. Hope it's been helpful. For soundtraining.net, I'm Don Crawley. Thanks for watching.